with the vermicomposting applies to regular composting, except because worms are in regular compost. It's just we've got a whole bunch of other guys in there. So we're going to talk about backyard composting. And we're going to talk about what it is, why we do it, how we do it, the process, how we can make it, and what we're going to do with it once we've got it. What is compost? Compost is a chemical and a biological process, whereas organic matter is broken down by microbes and bacteria, all sorts of critters, and turns it into a friable, soil-like substance that we can use in our gardens. Hi, Bill. Use in our gardens and provides nutrients, improves our soil. We'll get into that a little bit more. Now, composting occurs naturally. It's been going on forever. All our plants, all our organic matter that we have. It takes energy from the sun, it takes water, it takes oxygen. All our plants use all of these things. They create their bodies. Then when they die, nature takes over and naturally breaks it down into a substance that other plants can use. Man has stepped into the process. We like to get things going quicker. So man has figured out what we need to do with to get composting, the decomposition process, to happen faster. And I'll get into that process in a little bit. But why do we want to compost at all? Composting can improve our soil. It can improve the structure and the texture of soil. If we've got sandy soil, it can improve the nutrient and the water retaining capabilities of that sandy soil. If you've got clay soil, if you live in the mountains here, you've got clay soil, adding compost can add pore space. It loosens up the soil so that air and nutrients and water can get into that soil. Not only get into it, but also leave. In clay soil, it has great water retention capacity. So by adding pore spaces to clay soil, that water can drain from the soil. It prevents waterlogged plants. It also adds nutritional value. And compost presents a situation where plants can take up nutrients better. So it not only puts nutrients into the soil, it also allows plants to use those nutrients. And it suppresses soil-borne diseases. And why we want to compost, one of the reasons, is our landfill spaces. Our landfills are filling up. And a huge percentage of the materials that go into landfills are organic matter, which can be composted. So not only do we save on landfill space, which means we don't have to build new landfills as often, which saves us money that way as taxpayers, it also gives us this valuable soil amendment, which is going to save us money, not needing to buy fertilizers and other soil amendments as much. So from a financial perspective, it also saves us. What is the process? Organic matter, yard wastes, food wastes, garden wastes. In the presence of oxygen, air, and water. You've got your organic matter, your air, and water. It's then acted upon by microbes. Microbes, bacteria, little bugs, all your little critters, and your earthworms, just like in vermicomposting. They get involved in it too. And the end result is compost, compost, water, heat, and carbon dioxide. Now that's just the chemical process of what goes on. But basically, the factors of composting: air. Now we said we have organic matter in the presence of air and water. We have microbes working in there. We've got two types of microbes. Let me just go back. As I said, we've got your food waste, your oxygen, water, and the microbes, which are going to give us the compost. They need air. And you've got two types of microbes. You've got aerobic and anaerobic microbes. Aerobic meaning with oxygen, and anaerobic meaning without oxygen. Now the aerobic microbes, the ones that need oxygen. Think of your aerobics classes. You know, these are the ones that are really active. They're the ones that do the most composting. They get in there and they really break down your compost pile. They get in and they start really eating up all this organic matter that you've put into it. They need air. So once they get in, they use up all the oxygen, then they stop working. Then the anaerobic bacteria take over. And they both have a place in this process. But when the anaerobic bacteria take over, they're sort of like your couch potatoes. They're going to break down your organic matter, but they're going to take their time about it. They may take a year or two. So if you have a compost pile you just let set, it will break down. But it could take a year, could take two, could take longer. Which is why you hear people talk about turning your compost pile. Because you want the aerobic bacteria, the ones that need oxygen, you want to get them the oxygen because they're the ones who are really going to get in there and they're going to eat it up and they're going to break it down quick. So the more often you turn your compost pile, the more oxygen you're providing them so the aerobic bacteria can keep working on it. There will become a point in the compost process where the aerobics have done their work and the anaerobics do have to take over and finish the process. But for the most part, we want to turn our compost piles, give them oxygen. They need it. Moisture. Like just about all other organisms on Earth, these microbes need water. But they don't need too much water. Your compost pile should be the consistency of a wrung-out sponge. So that if you take a handful of your compost and you squeeze it, at most you might get a drop of water out of it. If you get more than that, it's too wet. Now, if you open your hand, you want that squeezed up compost to stay intact. If it just all crumbles, then you know it's too dry. The amount of surface area. You've got a piece of material, and it's covered with microbes, and they're all working on it. If you break it into smaller pieces, it allows more surface area and therefore more microbes to work on it. So if you put in a log, it's going to sit there, and it's going to take forever for your log to break down. You put that log through a chipper shredder and come out with, inch-sized pieces, that'll break down in no time at all. So if you've got a lot of woody material, if you've got a chipper shredder or something to put that kind of thing through, then you can put it into your compost pile. You could still put it in if you don't have a chipper shredder, but it's going to stay intact for a long time. You'll always, when you're harvesting your compost, you'll still be coming out with those sticks and twigs. So the smaller the pieces you can put in, the quicker they'll break down. Now, pile volume. Through, I guess, years of experimentation, they found out that the ideal size for a compost pile is a cubic yard, which is 3 foot by 3 foot by 3 foot. Now, not everybody's got that amount of organic material. You can have a smaller or a larger pile. A smaller pile is not going to heat up as well because you've got the effects of the outside temperatures. You get colder temperatures and they're going to cool down your compost pile. If you've got too big of a pile, you're not going to get air And as we saw, we need air and water for this composting process. So if you've got a big pile, they find that the air will not get into the center of the compost pile. Now, in commercial processes, they have huge windrows, but they've got machines that come and turn these things and put the oxygen into it. But unless you're out there and you want to turn a big pile, which is also more laborious, because if you've got a big pile, it's a lot more work to get into that big pile to get to the center of it. So ideally, a 3 by 3 by 3 foot pile. Now we're going to talk about the microbes. We've got a whole bunch of different kinds of microbes working on this. The composting temperatures, anything above freezing will compost, and below 180 degrees. So in the middle of winter, don't expect your composting to take place. Yes?
In the middle of winter, should one still be turning on compost?
No.
Because that's releasing whatever heat is there, so
it would do that as well, and everybody's pretty sluggish at that point too. Even if you've got a big pile, the outside temperatures are still going to work on, your pile and get to the center and reduce the temperature of your compost pile. So I say in the winter, just take the time off. Unless you're adding new materials. If you're adding new materials, you do want to incorporate them into it, and I'll discuss why in a little bit.
May I ask you one more question?
Sure.
Or should I wait?
No.
I think I killed my compost pile by adding too much grass and too much sawdust from my project. Is the way to cure that just by tossing it and turning it and breaking it up continually?
Well, if you added your sawdust and your grass, they should have been a fairly decent mix. The sawdust should have been offsetting your grass a little bit. Maybe you put too much grass in, and you probably do need more browns. But no, I wouldn't say you've killed.
So I'll just wait until the summer and see what I've done.
Well, you probably got leaves out there now. You don't have leaves? Oh. Bet you got newspaper. Cardboard box.
Yeah, I got it.
Okay, I got a cardboard. We'll talk about this in a little. Gee. Okay, the most efficient composters live at between 130 and 140 degrees. You can have a thermometer and you can check your compost temperatures all the time. As you start composting, you find out just by experience, you'll learn whether your compost is working. Most of us in a home compost bin won't get our temperatures really, really hot enough to kill all the pathogens off. But it's good enough to break down all your materials and get good compost out of it. So I've got a thermometer I never use. I'd say don't bother being fanatical about your temperatures. You'll be able to tell if your compost is working, because seriously, you can stick your hand into a compost pile and tell if it's hot. You can sometimes stick your hand into a compost pile and get burned too. Compost can get too hot.
What would keep home compost systems from
Size generally. And to get really hot, you want to have the really proper ratio. And a lot of, usually in the fall we're getting tons of browns. In the summer we're getting tons of greens. So unless you're really fanatical about, well, I've got so many greens, I got to find enough browns to offset it, to be sure that you're always getting the right ratio, that kind of thing. So in a business, they can be more conscious of having the exact ratio of carbon to nitrogen. But in the home compost, we're a whole lot less lax about that. We just want to use up our materials, or not use them up, but compost them. And the thermophilic, which, as Marianne told you, these are the heat microorganisms. They kill pathological pathogens at 113 to 155 degrees, which a lot of us, as I said, won't achieve in our home compost bin. Which is why later on, when we talk about what goes into a compost bin, why we'll keep some things out. Carbons are browns. You hear about the browns and the greens. Carbons are browns. Carbons are sugars, sort of like carbohydrates. They're going to be a good energy source for all these microorganisms in there. So throw in your browns, think candy bars, you know, they're getting in there. Yum, 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 they're going to really get working. But they also need nitrogen. They need their greens. That helps them synthesize proteins and build their bodies. You don't really think of microorganisms as having organs, but they do. So they need protein to actually build their little bodies and keep working. So we talk about equal parts of browns and greens, or 2 to 3 parts of browns to a part of greens. Again, a lot of it has to do with what you've got available and what your compost bin is telling you. And experience will let you know, and we'll go into this a little bit further. Your compost bin will tell you, I need some browns, or I need some greens. Yeah, I'm starting to really smell. You better throw some browns in here because I got too many greens in here, or I'm not getting warm, so you better throw some green material in there. And we'll get into that later. That was the smells and such. Where are you going to put your compost bin? You want to put it on a level spot. If you're on a hill, if you're on a hill here in the mountains, rain comes down, goes through, washes your nutrients, which are going to be washed down to the bottom of your pile, going to wash those nutrients downhill, which is pretty good if all your plants are down there. It might save you a little bit of work. But generally, if you can, put it on a level spot. Convenient to your garden or materials. Obviously, you don't want to carry your material or your compost too far. If most of your materials are coming from your garden, your harvest type of materials, your spent plants at the end of the year, all the stuff, all your dead plants, or you harvest your, I was going to say beets, but you don't throw away your beet greens. You pull your carrots up, you take the tops off of the carrots. If you're going to use, if that's where most of your green materials are going to come from, have your compost bin close to your garden. That way, when you finish with your compost, you can then take it and put it right back into the garden.